One of the biggest head scratchers in software is that when you start a project, it's nothing. It's just an idea, it's totally invisible. But you still have to put together a budget, a timeline, a whole schedule for it. So, how on earth do you measure something you can't even see?
Think about it like this. Imagine you're building a house. A contractor can't just give you a price or a finish date out of thin air. First, they have to know, are we talking about a cozy little cabin or a sprawling mansion? It's the exact same problem with software. Before we can even begin to guess the cost or the time, we first have to figure out its size.
So, where did people start? Well, the first and, let's be honest, most intuitive way they tried to solve this was super simple. Let's just count the thing we're actually making. Let's count the lines of code. And this method has a name, source lines of code, or just SLOC. It's basically the software version of counting every single brick you're going to lay for that house. And you can see the appeal, right? It's tangible, you could count it, you can even automate it. For a while, it seemed like the most logical way to measure size. But here's where that whole idea starts to fall apart. Take a look at this. On the left, you've got a little script in Python. On the right, a program in Java. Here's the kicker. They do the exact same thing. But the Java version takes more than 3 times the lines of code to get it done. It turns out the bricks are different sizes depending on the language you're using, which makes for a very, very wobbly ruler. And oh, the problems don't stop there. The line count can change dramatically just based on a programmer's personal style. Plus, you can't even get the final count until the project's already done, which kind of defeats the purpose of estimating. But maybe the biggest issue of all, it completely ignores all the really time-consuming work that isn't coding. Like design, planning, and all that crucial testing. So this forced the industry to make a huge mental shift. People started thinking, okay, wait a minute. Instead of counting the bricks, the technical stuff, what if we started counting the rooms? What if we measured the software based on the value and the functionality it actually delivers to the person using it? And this idea was a total game changer. This approach completely separates the size of the project from whatever technology you use to build it. Suddenly, it doesn't matter if the walls are made of brick or wood or straw. What matters is that the house has a kitchen, 2 bedrooms, and a bathroom. The measurement is all about what the user gets. Now, this didn't just happen overnight. This idea evolved over decades. It all started back in 1979 with a guy named Albrecht at IBM, who came up with something called function point analysis. Then it got simplified in the 80s, and finally it was standardized in the 90s with a method called COSMIC, which is now a full-blown ISO standard. The original method, Albrecht's, was really thorough. It involved identifying all the ways a user interacts with the system, inputs, outputs, things like that, then giving each one a complexity score. And after all that, you'd adjust the final number based on 14 other system factors. It was designed to capture pretty much everything. The modern standard, COSMIC, just brilliantly simplifies all of this. It boils everything down to 4 super basic data movements from the user's point of view: entry, exit, read, and write. That's it. Each one of those movements counts as one COSMIC function point. It's so simple, but it's elegant, and it works for all kinds of different systems. Okay, so now we have a size. It's a number, right? Whether it's in function points or maybe even lines of code. But a number isn't a project plan. How do you actually translate this system is 141 function points into a real budget and a real schedule? Well, that's where predictive models like COCOMO come in. It stands for Constructive Cost Model, and it was developed by a pioneer named Barry Boehm after he analyzed tons of data from real-world projects. Basically, it's an algorithm. You feed it a size estimate, and it spits out a prediction for the project's effort, how long it'll take, and even the best team size. And the single most important, mind-blowing insight that came from all of Boehm's research was this: software projects do not scale in a straight line. Doubling the size of a project doesn't just double the work. Oh no, the penalty is way, way bigger than that. And this illustrates a concept called diseconomy of scale. Just look at this chart. It's based on the COCOMO formula. A 20,000-line project might take about 150 person-months of effort. But if you double the size to 40,000 lines, the effort doesn't double. It nearly triples to 400 person-months. Why? Because as projects and teams get bigger, the complexity and the communication overhead just explode. So we've looked at counting lines, measuring functions, using predictive models. What's the right way to do it? Well, the reality is that a truly skilled estimator doesn't just use one method.
They don't have a favorite hammer, they have a full toolkit.
So let's just break it down real quick. Lines of code, or SLOC. It's useful for a fast analysis of a system that's already built. Function points, they are incredibly powerful for estimating a project from just the requirements, way before a single line of code is written. And COCOMO, that's the essential bridge that turns that abstract size number into a concrete plan. Each tool really has a specific job.
So in the end, there is no single best method. There's no magic formula. Good estimation is a skill. It's about understanding the project you're looking at and then choosing the right combination of tools to get the clearest possible picture of that invisible thing you're about to build. And all this leaves us with a really fascinating question for the future. I mean, for 50 years, these methods have all been about measuring the work that humans do. But now, as AI starts to write more and more of our code, what is size even going to mean? Are we going to measure the complexity of the prompt we give the AI, the cleverness of its output?